I'm Jens Hunhevicz from ETH Zurich, located in Switzerland, which is, you can see, very prominent on this picture. And I'll present you my conference paper today, which title you can read here. So it's obviously about DLT, which means distributed ledger technologies, the technical side, and how also about the applications in the construction industry and how you can maybe link these two together. So maybe I need to first clear up the term distributed ledger technologies. You might have heard of the term blockchain. It's more commonly known. These two names are not synonyms. So blockchain is one distributed ledger technology, and there are more, but it's the most prominent one. And if people hear the term blockchain, they often think of cryptocurrencies, and that's no surprise because Bitcoin was the first application of blockchain technology as a financial means. And so it's no surprise most people link blockchain to these financial applications, but there is more to it. And I want to show you now with Gartner's hype cycle. You have what I mean. You have probably seen Gartner hype cycle. Who has seen Gartner hype cycle before? Probably all of you, right? So we have blockchain there as one term, and we've embedded in a lot of other technologies, right? So eventually Gartner figured that this is not accurate enough, I don't know. But what they did, they published a new hype cycle which is only about DLT and blockchain. So all those terms you see there are blockchain related. And I just highlighted some few of them you might know. Cryptocurrencies is down there, smart contracts, blockchain and supply chain. Is just some very common applications and hyped applications right now. So why is this important for construction? So I don't want to go into too much detail here, but if you just look at this picture, you can see that construction projects are very complex projects. Often they are very large, often they are long-term, and often they involve a lot of people. That need to work collaboratively together to make this project happen. So for collaboration, naturally, trust is very important, and a lot of the literature agrees on that fact. And now you might say, we do have already a lot of digital tools available. Why do we need another one like blockchain? And in my opinion, building information modeling and this digitization of the built environment is just the beginning. Once we have these digital models, new technologies, other technologies can also bring some benefits. And blockchain, I believe, has some unique value propositions that could be useful in the future, also for construction. So to understand what I mean, you need to first know what blockchain actually is. And now I'm just interested, how many of you could explain blockchain to me? So not too many, that's what I expected. So I tried to explain blockchain in one slide. It's not so easy to do, but you can approach me later on if I was successful or not. So you might know ledger, and funnily we had accounting just a couple of slides before. So you might know a ledger from accounting, which is basically just a book, back in the days, now it's software, where you record all transactions over time. And you do that because you want to know the current state of your bank accounts, right? So you want to know the history, and you want to know what's the result, so how much money do you have in the end. So blockchain, at its core, is a ledger. But this ledger is set up in a very, very specific way, which brings some unique benefits with it. And I want to show you that here. So what you do, you cluster these transactions over time, and you put them into blocks. And you link this block to the previous block, and then there are more transactions. You put it again in the block, you link it to the previous block, and again and again. So what this obviously brings as a benefit, these circles there, the connections, are cryptographic seals. So on the one hand, you have the full transaction history over time, so you know which transaction happened in which order over time. And you also know if someone tries to cheat or to delete one transaction or just to alter it. So you recognize this and you can prevent it. But now this is running only on my computer, and you might not trust this right away. If I tell you this is the truth in the blockchain, you say, no. That's just on your computer, you could cheat, right? So a major component of blockchain and distributed ledger technologies is obviously to distribute this over several computers. So you have copies of the blockchain on a lot of machines which run in a network. So what you can do now, if I cheat on my left blockchain, the others that also have a copy immediately recognize the failure, right? So they see the difference and they can prevent it. And I don't want to go into detail how this actually happens. It's kind of complicated and not really relevant in this presentation, but they can do it, and the protocols running on top of the blockchain ensure that. And one important component is also randomness. So you always want to have, you never want to know where the next block is going to be added, because if you know on which machine they add the next block, you can cheat, right? So this randomness component is also very important and can be assured in different ways in a blockchain. So now I hope you have some understanding of blockchain. So what are the values? So if you look at some literature, transparency and traceability are obvious benefits of blockchain if you understand how blockchain works, right? You just have seen this. And more surprisingly, there is collaboration, which now it becomes very interesting. And another source also talks about building up trust through blockchain. And what they essentially mean, the whole history of transactions is immutable. And through this immutability and some of the other, we call this fundamental properties of the blockchain, like transparency, traceability, all these things ensure that the system itself is establishing trust. So you don't need to trust the users anymore in the system. So it doesn't matter if you don't know the counterparty you transact with on the other side of the world. It doesn't matter if this is a refrigerator or a human. The system itself ensures that you can trust the transactions. And then they have two other benefits listed there, which is reducing cost. And this is because it's a peer-to-peer transaction. It's often getting mentioned that you can get rid of these intermediaries. Banks are sometimes afraid of DLT because the technology itself allows for direct financial peer-to-peer transactions, so you might not need the bank anymore in between, right? So it's about this side of DLT that could reduce costs maybe. And accelerating transaction, and this often becomes true when you talk about cross-border transactions. So the paper I wrote here for EC3 addressed these two research questions. There are a lot of ideas how you can use DLT in construction, and I found these use cases. And there is a lot of different technical designs of DLT. So it's a very complex space. And my question was, how can you link these two? How do you know if you want to have one use case in construction, which DLT you should use to design this use case? And can these use cases be clustered into broader categories so you can have a general idea, a more general idea what technical requirements you need? So the methodology I went about is I reviewed technical DLT literature, I analyzed the fundamental characteristics of the technology, and I went with 4 design decisions. I'll show them to you later. And on the other hand, I also reviewed literature in construction. I identified 22 use cases, and I managed to cluster them into 6 use case categories based on their technical requirements for DLTs. And I did that by using a simple framework with a proxy I call level of trust. And how this all works, I want to show you now in a high level. So this is called the technology stack. We're at the computing conference for construction. So that's a technology stack, how blockchain works. So you have internet layer for information exchange, and then you have your blockchain, which is called DLT protocol layer. And you already know these two elements. I showed them you in my one slide explanation, ledger and P2P network. And these two elements are often very similar across different blockchains. And then there is a component called governance. And here it becomes very interesting because you have a lot of different opportunities here. And to show you that, I have listed 3 design decisions here. So you have public and private blockchains. These two are blockchains. And then you have a centralized solution like a cloud service you know nowadays. So I also have some nice pictures here. What a public blockchain basically is it doesn't matter who you are, you can join the network. You're allowed to read transactions, you're allowed to write transactions with no restrictions. Everybody can join. And then you have something called the private blockchain, which excludes some users. And you have restrictions who can join the network. And this comes with some benefits. So by doing this, you can have a faster system because you don't need so many consensus rules which ensure that all the transactions are correct and not manipulatable. So by trusting the users a bit, you can have a faster system, and you also have more privacy control over the whole system. But the system itself is, in the sense, less secure, so it doesn't establish as much trust as the system on the left. And then you have this centralized system, and of course they're run by intermediaries, so you completely need to trust the intermediary, the people operating the system. You cannot trust the system that it is right? It's kind of this blind trust we have in these companies right now, that our data is actually correct and secure, and they don't change it. So the opposite side is, if the system itself ensures a lot of trust, you need no trust in the users. If you have some trust in the users, you only need a system that ensures some level of trust, which ensures the main characteristics you want to have, like you want to have the transparency, you want to have the immutability, but only to some level. And of course, the centralized system, you completely need to trust the intermediary running the system. And guess what? Which system is faster? What do you think? Of course, public systems are way, way slower than the centralized solutions, because ensuring this trust comes at a cost, and you need to run all these computational heavy algorithms on top to ensure that nobody can cheat the system, right? So that's the level of detail I want to go in this presentation. If you have more questions, you can approach me later on. And I want to finish the technology stack, just to be complete, with the last layer, and it's an application layer which ensures smart contracts. Basically what this means is, if your DLT, your blockchain, allows for Turing complete language, which means it can compile bytecode, it can run protocol, it can run code on it, you can have these smart contracts, which basically are just scripts or code protocols on top of the blockchain, which ensures some transaction logic. So it's, if something happens in the blockchain, then do that. Very simple. And they are not smart because they're human coded. They're only as smart as the human that code them. And they're not contracts per se. So the name itself is very misleading, but that's the way they're called right now. So they're smart contracts. So going back to the other side of my paper, which is the literature from construction, I reviewed these 9 papers back in, it's by the end of last year. Now there are some more. And I came up with these 6 use case categories, and I just want to go through them very, very briefly. So these are the 22 use cases categorized into these 6 use case categories. So the first one is more about internal use of blockchain, and sometimes this is questionable if you even need a blockchain. Then transaction automation, which is the use of smart contracts for automating transaction logic. The record of transactions, which is taking advantage of these transparency and traceability issues properties blockchain can offer. And then 2 fancy words, which are called decentralized applications, which are basically apps on the blockchain, and decentralized autonomous organizations, which I will show later on in the presentation. And the last category is coins and tokens as payment incentive scheme, which is a lot related to cryptocurrencies and the financial side of blockchains. So this is just a more complex table of this design decisions I already showed you. So you have centralized at the top, permissionless at the bottom, public at the bottom, and the fundamental properties are increasing to the bottom, which means you have more trust from the system to the bottom. And of course, performance is decreasing. So if you know now that some systems imply a lot of trust and some imply almost no trust from the system side, I figured that you can go to the other side and you can ask yourself, if you have a use case, how much trust do you need from the system? So how much trust do you have in the use case itself? And for that, I came up with these 3 questions, and you can rate them, and you get an approximate value of where your trust level might be relative to other use cases, of course. So what you can do then, because it's inversely related to the trust provided by the system, you can just map the 2. So if you have a use case that has low trust in the community that is involved in the use case, you need a system that provides a lot of trust, so you have high fundamental properties. That's the basic idea of my framework, and that's very simplified now, and if you have more questions, you can approach me later on or ask questions. But what I want to do now is show you some of the use cases, because I think they're very interesting, and if you're not so familiar with blockchain, this might be more interesting also to see, right? So I want to show you some of the categories I came up with, and the transaction automation and optimization I already mentioned is a lot about what is the transaction logic of value transactions throughout the whole building process, from design to construction to maintenance, and where if you find these value transactions, there might be potential to automate them. So you can use these smart contracts to, for example, automatic triggering of payments. You can have incremental payments because there is almost no overhead cost to it. So you can have hundreds of payments within a short amount of time automatically triggered, right? So there might be potential for automated contract administration of contracts, automated sharing of information and data, you name it. There are a lot of ideas around how you can use these smart contracts for construction projects. So then you have also a category I call record of transaction changes in ownership, and it's often used in supply chain, also in other industries, and it's one of the more famous use cases. What you do is basically you track your goods throughout the whole supply chain and you record it on the ledger. So by the end, you know where it was sourced, how it was transported, if child labor was involved, if it was sustainable, and, which brings a lot of transparency to the end customer. And I would say it's just a matter of time until this technology is not only used in food, but also probably in construction, which just changes the whole game. We have a very intransparent supply chain at the moment right now. But you cannot, it's not only used with physical goods. Now the computer is not responding anymore. Okay. So you also can use it in digital models. So you can imagine a BIM where you can record all transactions, who added what, who changed what, who added which document when, which might be important for liability reasons later on, or you can also think of other use cases. So this is not only limited to physical. And then I want to show you this term, decentralized autonomous organization, which is a very fancy term to set up a blockchain so you don't need human involvement anymore. And one use case gets mentioned in literature is automated maintenance systems. And how do you do that? It's basically you encode the transaction logic into the blockchain. So you need a blockchain, and then you combine it with other technologies. So you have a digital model, which so that you know where things are located, And you add sensors, so you have a connection to the real world, whatever you want to measure, right? So you can actually then think of a lot of use cases like automatic ordering of spare parts, automatic ordering of like maintenance staff. So basically the idea is that the system can take care of themselves. And you also find some very visionary sources that they say this is even possible, that they can own themselves, right, and operate themselves. So this is very visionary, very far in the future, but it shows maybe a bit what the potential of this technology might be when it will be advancing in the future. So the last category, it's just what I'm very interested in my PhD, is this payment in cryptocurrencies and shared risk-reward incentive schemes for construction projects using blockchain technology. So I think I'll wrap up here. In conclusion, my paper gives you an overview about what DLT is, what use cases in construction are around. And I provided this simple framework with this proxy level of trust, so you can reduce the gap between the two, and you can see where the connection is actually between the technical side and the use case side. Of course, there are a lot of limitations. This framework is very simple. This level of trust is determined rather subjective and in a certain range. So the results are not as accurate. But I think this simplicity also allows for a good understanding of what is really important, I think. And once you have a good understanding of that, you can also consider other factors like technical stuff with throughput of the blockchain, scalability of the blockchain, and. So these are also things you need to consider in the end, but maybe it gets too complicated if you try to consider them all at once. So still a more sophisticated framework is desirable, and also with more DLT design options. I have these 4. Of course, you can consider hybrid solutions, you can have more, there is more, and it gets very fast, very complex. And the use cases are still evolving. This is a moving landscape right now. It's a very new topic in construction. And we also have no proof of all these benefits yet. So there is no case studies, no proof of concepts right now, to my knowledge, in construction. There are in other industries. So I try to change that with my PhD, and I hope I could spark your interest in the topic and maybe trigger some more research in that space. I think it's a very, very exciting one. So thank you for your attention, and I'm open for your questions.